Welcome to our workshop, Advanced Load Balancing with Traefik 2.5. Hope everyone can hear me all right and see the title slide. Looks like everyone can. My name is Dylan. I work here, and it's my pleasure to introduce today's speaker, Jakub Hayek. Jakub is our product adoption specialist here at Traefik, and he's put together a workshop to showcase one of the new exciting features of Traefik 2.5. Which is weighted round-robin load balancing with nested health checks. To showcase this, he'll deploy Traefik 2.5 on Kubernetes. This is a workshop, so we welcome all questions throughout the presentation. Please chat them to us. We're not really using the Q&A widget. We'll do our best to get to them. We will probably have time to answer a few questions on the fly, but if there are more than that, then we may need to address them offline. We will follow up afterwards. Don't worry if we move a little fast in this workshop. We are recording it, and you'll receive a recording once we're done processing it. And then finally, if you have questions after the workshop, you can always reach us on Twitter at Traefik. So Traefik, or via our website, which is traefik.io. All right, Jakub, the floor is yours.
Thank you, Dylan. Hello, everyone. So as Dylan mentioned, my name is Jakub Hayek, and today I'm delighted to give you a hands-on workshop about advanced techniques in the load balancing techniques with Traefik 2.5. We'll be running everything on Kubernetes cluster. So I'm using presentation, but most of the exercises will be actually executed in the terminal. So the presentation is just needed to help me follow up the entire flow. Okay, so let's move forward. So my name is Jakub Hayek. I work for Traefik Labs. I'm product adoption specialist. I help customers to adapt our products. I help with supporting them in case of any problem, in case of any issues. You can find me on Twitter, on community forum, where I try to answer some of your questions, as well as on GitHub. So, for those who are not familiar, what is a Traefik? Because maybe you are not familiar. What is it? So, just a few words about that. What is a Traefik? So Traefik is actually edge router that is working on the top of your infrastructure, and it might be in Kubernetes world, it's an ingress controller that is deployed and is getting incoming requests. It might be HTTP, TCP request, UDP, gRPC, and try to redirect that request back to to your infrastructure, to your backend services. So it's not a web server, it's just a cloud native edge router that has been designed from the beginning to act as an edge router. And Traefik is able to do some tweaks with your incoming requests, with a request in general, to use middleware, because we have something like middleware to tweak your requests. We can assign basic authentication, we can create we can remove specific headers. We have a circuit breakers and many other features that you can go to our website and go to the list of all existing middlewares. People also love Traefik because there is a Let's Encrypt integration, so you can easily generate and issue certificates without adding any special features. It just works as a out of the box. So what are the prerequisites for that workshop? So a couple of months ago, we recorded Getting Started with Traefik on Kubernetes, when I covered all basics. So we started from the beginning. We deployed Traefik on the Kubernetes cluster. We will also do that today. And we went through all concepts. What is the ingress? What is Kubernetes? How the Kubernetes networking works, and where the ingress is actually placed in that entire ecosystem. So we went through the ingress, standard ingress in Kubernetes, our implementation of ingress from CRD, that is the ingress route. and we try to do some basics. Today we are going to do a little more advanced work. So if you are not familiar with a workshop one, I encourage you to have a look on it. What else do you need? Definitely you need the Kubernetes cluster. You need to have Helm installed because we will deploy Traefik using a Helm Git to deploy my repository. Here is the link to the repository. It's already available, so you can copy and paste that URL and clone the repo with all examples that I'm going to present today. And yeah, I think that's all in regards to the prerequisite. We can move forward and start to working with a real scenario. So let me switch to my terminal. So I'm already connected to the Kubernetes cluster. I think you should see the my terminal. So let me try to check the connectivity to my Kubernetes. Yeah, Kubernetes is up and running. As you can see, there are 3 worker nodes, 1 master node that keeps the cluster state. Everything is deployed on AWS, but it's just a very simple installation. This is not EKS, this is just a very simple deployment. And let's go to the README file and let's deploy Traefik using the actually default values from Helm. What values I'm going to set up? It's actually all of them are listed here. So what I'm adding here? So I define the image, the tag. Actually, this is the latest Traefik. It's not necessary to specify it, but this is the one of the option that you can do to add your to specify the tag you are going to deploy. So we'll deploy 2.5.3. We enable provider Kubernetes CRD and allow cross namespaces to use services, to use resources from the different namespaces. And we are also passing specific additional arguments to Traefik. So we enable certificate resolvers. So we allow to Traefik to talk to Let's Encrypt servers in order to issue certificates. In that case, we'll use TLS challenge. As you can see, I defined 2 certificate resolvers, one for staging environment and the second for production. And I define my email address. So if you are trying to reproduce it on your site, please make sure to change it to your own IP address, email address, excuse me. And we also enable the persistence because Traefik is keeping Traefik is keeping the certificates in the file, but in the future we are working on the new enhancement that there will be no any persistence and Traefik will be fully stateless application, and those certificates will be kept in the Kubernetes secrets. And we also enable logs. So yeah, I think I already discussed it. Let me try to deploy Traefik using the Helm's values. So in order to do that, you need to add repository. So this is the first command you need to execute in the terminal: Helm repo update, and create the default, create the namespace where the Traefik will be deployed. So those commands I already executed, so I'm not going to do that, but I will create the namespace. Create namespace Traefik. I will switch to that namespace. No resources, and I will deploy Traefik. I will go to the directory Helm upgrade, install Traefik. Yeah, Helm resource Traefik.values.yum. Yeah, so the Traefik is now deploying using the Helm. As you can see, the process is already finished. It's already completed, so Traefik should be deployed. Let me check. Yeah, the pod is just creating. There is also service created, but not yet. Let's wait a little bit until it will be started. So as you can see, the status has been changed to running. Yeah, it's already all health check props has been finished. So it means the Traefik is now up and running. Let's try to describe the defaults that we set up in the values. As you can see, I executed the command describe deployment traffic, because we deploy traffic as a deployment in Kubernetes, and we do have all parameters, all arguments that I added to the values.yaml. So we have entry points that are, because yeah, I used just a couple of them, but if you will go to our Traefik Helmchat repository, you will notice that there are much more values that you can set up, that you can configure it according to your needs. So I just used those that I wanted to change. So I didn't specify entry points. I didn't specify, for example, metrics or ingress, because this is the default values that are taken from our values.yaml file. As you can see, there are also liveness, readiness, health check props, volume, and volume has been already mounted as a PVC, so everything should work correctly, right? Let me check whether a service has been created. Yes, service has been created, and as you can see, it points to the external IP. This is a load balancer type of service. It's a Kubernetes resource, and it points to the external IP that is provided from AWS. Now I will just add one extra command that is specifically required only to my environment, because I will be creating lots of domains during that session. So I need to have any wildcard record that actually points to that external IP provided from AWS. So we use a Cloudflare. The domain that I'm going to use is hosted by Cloudflare. So I will just send the command to the Cloudflare API to update, to create specific wildcard DNS entry that will resolve to that IP address. So it will take it's already created. So as you can see, we have a wildcard record CNAME created that points to that external IP provided from AWS. So the first step is finished. We can explore Traefik dashboard. Let me show you the dashboard for those who are not familiar with dashboard. We will use kubectl port forwarding, because we will not create the routing for that. This is covered in the first workshop. So we'll use port forwarding to access dashboard. So let me try to do that. In that terminal here, port forward. Yeah, forwarding is up and running. So we can go to localhost 9000 dashboard, and we should see dashboard, default dashboard that is provided in the installation of Traefik. So as you can see, there are the entry points that are already available, HTTP routers, services and middlewares, TCP and UDP routers. As you can see, there are no any routers yet created. We enabled a couple of the features, metrics and access logs, and there are two providers available. So Kubernetes Ingress and Kubernetes CRD. So as you can see, there are 3 HTTP routers. So let me go there to see what are the routers already created. So as you can see, there are default routers that are necessary to be added in order to, for example, see the dashboard, right? So this is the actually path prefix that is being used to access the dashboard and the default services. And we will be using the dashboard for entire presentation workshop here, because each of the component that we are adding, it will be presented here. Okay, so let's go further. Now we need to deploy sample applications. So let's go to the step number 2. And let's explore what is inside. So we can go to we create the namespace, because it's a good practice in Kubernetes to deploy all the resources in their own namespaces. Deployment, and this is a very simple application. If you are following Traefik Labs, you know that we have an application called Who Am I that presents some headers from the inside the container. So in that case, we will deploy the application with one replica, and we will pass the arguments ASCII and the name foo. We will enable the readiness prop, some of the resource limitation. And the second applications will be the same base image. However, we will change the name here. So the differences between those two apps will be that if I will go to the V1, I will get in the response foo, but if I will go to the V2, I will get in the response bar. And the standard Kubernetes resources called just a cluster IP services. So nothing fancy here. Let me deploy it. kubectl apply -f 00 namespace. Namespace has been created. No resources. Let's deploy apply -f 01 deployment. Resources has been created. Containers are being started. Services are already created. We can run very simple toolbox. Actually, I like that kind of tools to test whether those services are up and running. So what I just did, I ran the temporary pod on my cluster when I have some tools, for example, curl, to call that services to see whether my applications are up and running. So who am I? V1. And as you can see, I'm getting the response from the application. So I use the cluster IP service and I connected directly to the application to get the response. So it presents foo. So I'm sure that I connected to the right app. If I will change it to the V2, I should expect to have a bar. And it works correctly. So we are good here. I log out from the container, from the pod, so the pod is already deleted, and now we can expose the same application, but through the ingress route that I'm just going to present you. So yeah, that's the CRD that we are going to deploy. We use a certificate resolver here for let's encrypt that I defined at the beginning of the first lesson, first exercise. We use an entry point that is called web secure because we will expose that application only through HTTPS. We use a matching rule. As I mentioned, Traefik is matching incoming requests based on the specific rule. And in that case, we are using a host, HTTP host header. So when Traefik see in the incoming HTTP request host that matches that name, it will pass the request to that Kubernetes service. So v1 asd demo traefik-labs.tech should give us the answer foo. And the same is already created, but for v2, for the application called bar. So we have two ingress routes, v2 and v1. So let me apply it. Yeah, it's already created. We can explore it. Describe ingress route, who am I, v1. And as you can see, all those, the Kubernetes manifest has been deployed, and this is how it looks like if you describe the object. So everything matches the file that I'm just presenting. And if we will go to the dashboard, we should see that there are new objects created, right? So we have two new rows added. So it's a v1, v2. We know that it's already protected by SSL certificate that should be issued hopefully from the Let's Encrypt, and it is exposed through WebSecure. It dynamically created the name of the router, name of the services, and the provider is Kubernetes. So let me go to the services. Yeah, as you can see, we have two services. The type of those services is load balancer, and there is a one replica inside, right? Because we deployed the one replica. If we scale up the deployment, you will see that new pods should appear here. Okay, so let's try to see whether those apps are up and running. HTTPS v1 ASD demo Traefik labs.tech. And yeah, works correctly. As you can see, we have a certificates already issued from Let's Encrypt. So it's a valid issuer, valid host for the domain. The same we can do for V2. Yeah, so those are basics. We just deployed services, we expose them through ingress route. There are no any special features that are related to the advanced load balancing, but those are actually starting point for moving forward. So let's go further and to see what is the next step. So the next step is weighted round robin. So let me show the diagram to explain how it works, right? So we have a Traefik proxy deployed and we have a Traefik service. A Traefik service is an abstraction layer that is a part of our CRD, and it is running on the top of the standard Kubernetes service objects. And you can use, for example, weighted round robin and use that feature to provide progressive deployment. So for example, canary deployment is one of the type of the progressive deployment. So you can deploy two versions of your application, V1 and V2, and based on the weights defined on the Traefik service, you can distribute your traffic. So if the weights is larger than that weight, most of the traffic should goes to the V1. And if you have any extra tool, for example, you are doing a production release, you deployed version V1 that is actually production ready, but you also deployed version V2 that is the newest version of the application. So you can test on the production in live environment how that application behaves. And if you set up those weights correctly, just a few users will be able to hit your application, and you can see what's happening inside. I mean, what are the responses if the application, if that new version of the app works correctly, if there are no any errors. If so, you can change your weights and migrate the application from V1 to V2. We are not going to present that today because for that you can create more, you can use more advanced tools for that. For example, a Flagger Argo rollout to help you with creating a progressive deployment. But all of those tools use actually Traefik service to do that work, right? So we know how it works. Let's try to do that in the real example. However, before moving forward, I have a question for you. You can try to answer that question during the session. So the question is, where does the name canary deployment originally come from? For the 5 person who answered that question correctly, we will have some gifts for you. So yeah, you can go back to the slides. Yeah, so let's go to the tests, right? To the exercises. Yes, sorry. So yeah, we have a Traefik service. And as you can see, again, this is something that is this is a CRD Traefik service. The name is a weighted who am I, and we define the weighted here. Specific in the spec, we have a weighted. We have 2 services: who am I V1 and who am I V2. So the same what I presented in my diagram. So let me deploy it. 0.3. I notice answers already. Yeah, that's already deployed. Let's go to the services, because we added new service, weighted. As you can see, it's a little different than comparing to the other because it's a weighted, right? We created a weighted service that is abstraction layer running on the top of the Kubernetes services. And as you can see, there are 0 servers, but it should point to those two, v1 and v2. Okay. And now we will create the ingress route, and we will route the traffic for that host to that traffic service weighted service. Apply 01. It should be created. Let me check. Yes, it's new, has been added. As you can see, it's up weighted who am I, so it refers to the traffic service that I just created. Let's check whether it's running here, and we should be able to, yeah, it's added who am I WRR. So the curl HTTPS v ASD demo traffic labs.tech. No certificate yet generated. Let's try to use K. And as you can see, if I'm sending the request, I randomly redirect it to foo and sometimes to bar, right? So as you can see in the diagram, we are going back to diagram. Some of the requests goes to the v1 and some goes to the v2. So that's what you can actually do and proceed with canary deployment. But you can ask, let's say I deployed the 2 version of the application, so how to redirect for example, my testers to the v2. So what I can do, because I have that installation, I have a monitoring tools deployed, I can check what's happening on the v2, but yeah, I would like to ask my testers to go to that application, right, and check whether it's up and running correctly. So how to do that? We can create another rule and use a custom header to do that. So I have let me go here. I have a specific middleware that is going to create it that is called let me in, and that header adds specific request headers, right? The header is called xcanary header and the value is knock knock. So let me apply it. 03 custom header. And now we will create a new router that actually use a little longer matching rule, that it will take under consideration host as well as the header. And if that matching criteria will be met, we will be redirected to the v2. So doesn't matter what we are, if we are on the live environment, we still can hit the v2 and test our entire new release. What I should also mention here, that we attach the middleware that I just created. And it's also worth to mention here that in that case, we should think about the priorities in the routers, because we use the same host header, and which header has a priority. We haven't defined anything yet. So if you didn't specify priorities, Traefik will count the priority on the length on that matching rule. But if I would like to, so that rule is longer, so it will have a higher priority. But in some specific circumstances, you need to change the priority. But so it's worth to mention that you can read more about it in the documentation. So let me apply it. -f04 ingress route of header. Get ingress route. Yeah, it has been deployed. So now if I'm sending that request, as you can see, I'm always redirected to bar. Doesn't matter how many requests I sent, I'm still redirected to bar. So now you can use that feature to test your application on the production, on live environment. But if I will remove the header, I'm redirecting to foo and sometimes to bar based on the weights I created here. So it's a pretty nice feature. It's commonly used with more advanced tools, like for example, Flagger, Argo rollouts, or any other to provide canary deployment in a real production environment. But yeah, it's nice to understand how it works and how you can achieve that even without those tools, but just creating those simple configuration. So what's the next? The next is mirroring. So how mirroring works? In that case, we will also explore Traefik service, that is abstraction layer running on the top of the Kubernetes objects. And we'll use the same V1 and V2 services. But in that case, when we send the request to the V1, some of the requests will be also sent to V2. But in that case, there will be no response sent back to the user. So that's important to understand how the mirroring works. So let me repeat once again. We are sending requests to V1 and 50% of the request goes to the V2. So this is how it works, right? Let me deploy it. Let me go to the configuration and let's try to see how it's configured. So Traefik service, again, Traefik service, the main service is V1, and here is the list of the services that you can specify here. So we can have more services added here, and some of them will be added. Some of the requests will be also sent here, but again, no response sent back to the user. So you can even have 500 or any other error, but none of the users will be affected. So let's go and let's deploy it. I see the question, where is the repo? Let me answer it. So here is the link to the repo. Okay, thank you. Yeah, let's apply it. 0.0 Traefik service. Yeah, it has been just added. And as you can see, the mirror service is V2. So this is how it looks like. And now let's create another ingress route for that. Yeah, I have something wrong with indentation. So let's go here. So in that case, again, we use very simple, already known ingress route definition manifest, but we use the newly created Traefik service here. So kubectl apply -f01 ingress route.yaml. It should be already created. Let's check. Let's give a second once the new certificate will be issued from Let's Encrypt, because previously we got a warning, but now it works. Okay. So now if we will go to masd demo Traefik labs.tech, again, let's use K. So as you can see, we now getting response only from foo, but we don't have, unfortunately, we don't have a logs on the whoami application access logs, but the requests also are being sent to bar. So in case of problems with the bar, you as a sysops, as a DevOps engineer in your organization, you definitely notice the problems on your application, but your users won't be affected. So it's a very nice feature that you can use it on daily basis to test your application on the live environment, because we can build as many staging environments, but it's very difficult to keep them similar, very close to the production. So that's why we have a feature something like that to test the apps on the production environment. Yeah. So I removed -k, so certificates are already issued. So that's the mirroring, how it works. Unfortunately, I cannot show the logs from bar because whoami does not produce any access log. I was thinking to add any nginx deployment here because and enable access log, but you have to be sure that the logs, that the requests are hitting the bar pod. So what's the next? The next is sticky session. Okay, so the sticky session. Sometimes if you use any application that keeps the state on the backend, you need to avoid load balancing, distributing incoming traffic between other backends. So you need to make sure that those apps, those requests will hit the same whoami application, right? So if I will once set my session on v1, I should be the next my request should goes to the same backend. So how to do that? We can use the cookies to manage that. And we will use two levels of cookies, level 1 and level 2. And again, everything will be managed on the Traefik service. Let's go to see how it works. So that's the Traefik service. The name is whoami sticky session. It's the type weighted, and the stickiness is achieved by adding those two cookies. The first one is cookie level 1, and the second is level 2. There are also other parameters here, but we are not just going to focus on it. So let's try to create it. 0.5. -f. Oops. It's created. Yeah, let's also create ingress route for that. But let's check where is func. AST. Yeah. Okay, let's go to dashboard. Yeah, service has been created. As you can see, it uses sticky feature based on the cookie, level 1 and level 2. And the new router is also created. So that's the new router, and it redirects us to the service sticky, right? So we should be able to see how it works. Curl HTTPS S, right? Hopefully certificates are issued. Yes, they are issued. Yeah, and we can go to the browser to see cookies. ASD demo Traefik labs.tech. And if you open developer tools, we see that the new cookies has been created and they are generated by load balancer. And each time when I refresh, I'm hitting always the same application, right? But now let's try to change weights here. And let's say, let's add here 100 and let's set here just 1. Let me apply it. So I change cookies, change weights, nothing actually changed in my browser. I'm still hitting full. So that means the Traefik is keeping the state, keeping the sticky session and forwarding me to the appropriate backend. But if I will delete those cookies, I should be redirected to bar. Yes, so it works as expected. I changed the weights, so most of the traffic should goes to the V2, right? Yeah. So this is how stickiness works, right? If we'll go to curl command, if we'll execute with dash with VV, we should see the cookies here, right? But yeah, but in order to hit the same, we need to attach it to the request, right? So it's better to use here in the browser. Okay. So the last one is, I think, the most advanced technique. This is this is called nested health checks, and this is actually the new feature that has been released in 2.5. Currently, is only available in the file provider as a part of the dynamic configuration. So in order to use it, you need to create a simple configuration file and attach that configuration to your Traefik instance. But this is a cool feature because it allows you even to create global load balancer, help you with a migrating application between legacy and the Kubernetes clusters, because you can refer on the external URLs here, and you can also consider health checks on the Traefik service. So in case of failure, one of my app here, Traefik service, Traefik itself will be able to discover that something is happening with one of the app and will not route the traffic to the unhealthy application. So it's a pretty cool feature. And let me show you how it works, how it looks like from the configuration perspective. So in order to do that, I need to have a config map, because somehow we need to place that configuration on Kubernetes cluster. So that's the part of the dynamic configuration. And we have a HTTP section, services, who am I public, and the weighted definition here. And just the health check, but it creates, it is trying to do a lot of good work, because it's trying to check what is the condition of who am I DC1 and DC2, because you can think about it that it's a separate cluster, separate URL, or maybe any legacy, any other VM in your infrastructure. So you can do that. You can use it for different purposes. So it's super nice feature. So I have a health check enabled. I have a services, and I redirected between DC1 and DC2 using the same ways that I presented at the beginning. However, all those health checks will be taken under consideration on that who am I public service. And here is the router. So the router is exposed through entry point web secure. It used host nested ASD demo Traefik labs.tech and the service who am I public, and it also used certificate resolver Let's Encrypt. But in order to deploy it, we need to add some changes to the values.yaml. So first of all, we need to enable file provider and point to the dynamic configuration, right? So it's a config dynamic.yaml. And we also need to mount volume, because config map in Kubernetes are mounted as volumes. So we need to first create the config map and also add some changes to the values.yaml in order to mount that config map into my pod. So let's try to do that. Apply -f Traefik config. Let me check the namespace. Namespace Traefik, okay. kubeNS Traefik, CM. Yeah, it's already created. And now let's upgrade Traefik. So I execute the same command, but I should have a revision too, because I just redeployed Traefik. As you can see, I lost the connectivity to my Traefik instance, This is expected because Traefik is now creating and we have just only one replica. Okay. Okay, it's running. It should be reachable in a second. Yes, it's 1.1. Let's forward it. Let's go to dashboard. And as you can see, we should have a new provider, file provider enabled, and nested ASD is already running, right? So if I will go to the HTTPS nested ASD demo Traefik labs.tech. Okay, let's wait until certificates will be. Yeah, as you can see, I'm redirected again between bar, foo and bar, right? But let's try to, so it works as expected. Yeah, certificates are already generated, so full bar, right? But now let's try to scale down kubeNS app get deployments, because we have 2 apps, as you remember, deployed. Let's try to scale deployment. Who am I in V1? V1 to 0 replica. So we don't have any V1, right? But now we are still hitting nested URL, right? And we should be redirected to bar. So the application, the Traefik, were able to detect that there are some problems with the application foo. And in your case, it might be a separate cluster. It might be absolutely separate URL that is not even hosted in the same data center. So now if we will scale back to 1 replica, in a second the Traefik should be distributed across 2 deployments, right? Yeah, foo. So now Traefik goes to foo and the bar, right? So this is how nested health check works. And yeah, we use in that case services that are exposed by Kubernetes resources. But again, in that case, you might use external URL. So this is a very nice feature, and we will be providing that also in the as an ingress route, because currently it's only file provided, but still, as you can see, you can use it. It's maybe a little more difficult with the implementation, but it shouldn't be any problem. Okay, so that's all that I prepared for today. Let me go back to the question that I asked. So that's the last slide. So I asked, what's the canary deployment originally come from, right? So the answer is following, that in the 20th century, coal miners, they used canaries in the coal mines as an early warning signal for toxic gases, especially carbon monoxide. And because those birds are more sensitive to the toxic gas, so they will die before it becomes dangerous for humans. So it allows those guys to escape, to evacuate themselves from the dangerous places, right? So the same we can do with our application. If something is happening on the website, with the new release, you can easily remove it because you can test it on the very small number of users, right? So just only a few of them will be affected, and you can easily remove that by playing with the Traefik service and weighted round robin, or using any advanced tools that again use Traefik service to play with weights. So that's all in regards to the presentation. I think we can go through the questions because I think there are a few of them. Let me go from the, yeah.
Yakub, I have compiled the questions in your chat.
Yes, thank you. Thank you, Dylan. Yeah. So let's go from the question is following. Let me go start from the latest. Can nested health checks also be configured via Traefik service resource? For now, unfortunately, no. And let me explain why. Because Traefik uses service discovery using the endpoints. Endpoints that are, again, resources from Kubernetes. And if the service is down, there are no endpoints. There are no endpoints exposed. So Traefik service don't know where to route the traffic. So unfortunately for now, it's not possible. Configuration is already prepared. I already have it on my repo, but it's not ready to use. We will shortly add that feature to the ingress route. So for now, you can use only file provider. I hope you answer your question. The next one, can you mix Kubernetes CRD provider? Welcome. Can you mix Kubernetes CRD provider and file provider in one Traefik deployment? Yes, definitely. Definitely you can. As you can see here, you can have many providers available. So provider file is one of the type of the provider. We already deployed, we already enabled Kubernetes ingress and Kubernetes CRD. So yes, they might be, they can work together. Stickiness only works using cookies ATM. Our app is embedded in a frame and we don't have access to the embedding page. So that we set the cookie from the parent page. This is great sticking software. Is there support for IP-based stickiness? I don't know. The question is there support for IP-based stickiness? I don't know, but I will back to you with the answer. I will make a note and I will answer it later on offline. So you can contact me on Twitter. So my Twitter is, that's my nickname, and you can contact me. I will try to answer you, provide the answer or even the example. Yeah. Can I scale Traefik controller? So controller is only available in the Traefik Enterprise. In Traefik Community Edition that we are now exploring, there is only Traefik proxy. And yes, you can scale it up, but you need to think about the persistence, right? Because if you have a persistence enabled, you cannot have a more replica that read and write to the same persistent storage. And even if we add new feature that all certificates will be stored as a Kubernetes secrets, it's still not the case of having more replica for Traefik proxy, because the challenge is not with a challenge is actually with when you issue certificates, because you need to make sure that if you start issuing certificates from Let's Encrypt, the challenge process should hit the same instance that start the conversation. And that's why it allows, that might generate some problems, because you don't have an influence with working with with Let's Encrypt. That initiated process will be continued on the same Traefik instance. So you can scale it, but on your own risk, right? What are the other questions? Stickiness, we already answered it. There is a cool feature like HPA, horizontal port autoscaler. Could you please explain a bit more about it? So it's a Kubernetes, yes, of course, it's a Kubernetes feature that allow you to scale horizontal scale pods based on the three metrics: CPU, memory, or custom metrics. And yeah, in most of the cases, the best option is to use custom metrics, I think, but it's not related to Traefik at all. So yeah, it works. But again, if you are considering adding HPA to Traefik proxy, uh, you need to also think about that persistence that I just mentioned. In enterprise, this is already solved by controllers because there are two different components, but this we are not talking about the enterprise today. So definitely you can scale up Traefik proxy, but you need to think about the persistence. Is the Traefik proxy running inside or outside Kubernetes? Traefik proxy is running inside the Kubernetes as a pod, as a deployment here. So, and then as a pod. And how can you scale this if needed for human? Yeah, so you can scale up by adding more replica. So if you need more, if you have a more traffic, incoming network traffic, definitely you should scale it up by adding more replicas. But again, persistence is kind of a maybe not blocker, but you should consider what to do with that. Maybe you don't need a Let's Encrypt, so that's not problem with scaling up. In case of canary or mirroring, what if the apps were in different cluster instead? So there is no problem if you use nested health checks. So this is the feature that is designed to be used for having the application deployed in the different clusters, different data centers. So this is what you should use it. Because as you can see, we have still weights here. So you can do the same using the Traefik service, using the Canary and Traefik service. And I think, yeah, this is the all question that we already have. If there are more questions, definitely we can take them offline. I see more question.
Yeah, Jakub, it's up to you. So we can either answer them
Yeah.
now, or take them offline.
Yeah, so is it possible to use access mode read write many? No, that's not the case. Yeah, but believe me, it's not such a easy way to change the read write many for persistence. So the question is, can we just change read write many here? No, that's not the case. As I mentioned, the problem is if you issue certificates with Let's Encrypt, because your process, your instance start talking to the Let's Encrypt servers, and Let's Encrypt will challenge you, and you need to make sure that that communication will be handled by the same instance, and you don't have influence on it because there are no any controller to manage that. So that's the in that case problem is persistence, but there is also another problem that is related to issuing certificates. And believe me, we spent hours discussing the topic on our engineering team because we would love to solve it. But for now, it's not the case of the just changing read write too many. How to add response security header on Traefik. So I think it was covered in my previous workshop. I added, let me show you my GitHub repo, Traefik workshop, and security headers were added probably here, not here. Yes, I think it should be done here. Yeah, so as you can see, there is a rule, and there is also the security header, middleware that has all security headers attached. And some of them are explained here. So this is how you can do that. Using that middleware headers and assign specific header. There are more headers definitely that you can add to increase the security of your Traefik proxy instance. So that's all. Okay. That's all what we prepared for today. Thank you a lot for joining us. Thank you, Dylan, for managing the session. Hopefully you like it. Let me know in the comments.
Yes, thank you, Jakub. Excellent presentation. Thanks everybody for joining. If you didn't see, I put some extra resources, links in the chat. I'll also include those in the follow-up email, just so you have them. So don't worry about jumping on those. But you can always reach out to us, and we'll see you next time.
See you next time. Thank you a lot. Bye-bye.